And for this I'm looking to how I was taught math. I think an interesting analogy is to look at textbooks in other disciplines, right? If you look at English textbooks, there's something qualitatively different between a middle school English textbook and a senior English textbook. And both of those are qualitatively different from a third grade English textbook. But if you look at math textbooks, qualitatively they're all the same book, right? They're structured identically. They're structured identically. The math book that you use in third grade has chapters that are broken down into sections. Each of those sections teaches you one mathematical concept or one mathematical application. And each of them has at the end of it a big pile of problems. And usually what you do with the book if you're a student is you totally ignore the text of the book, right? You pay attention in class vaguely to hear what the teacher says, and then the teacher makes you work through a bunch of those problems. That's what you do in third grade math. What you do in seventh grade math is the same thing, only the problems now have letters in them instead of numbers, which is a little bit traumatic, but well, you can figure out the rules for what to do with letters. And what you do in senior math, in calculus, is the exact same thing. You have a book, it's broken down into chapters, broken down into sections, each one teaches one mathematical concept. At the end of it, there are a bunch of problems, only now the problems take a lot more time than they did when you were in third grade, right? Qualitatively, they're all the same book. There's no progression in math except for the Sisyphean progression of harder problems. That's how I was taught math. So the winning strategy if you're a student, right, how do you deal with that, is you memorize how to do the problems. It's like a cookbook. There's a recipe. If you're going to do an optimization problem in calculus, here's how you set it up and here's how you do it. Then when you get to the problems in the back of the section, you see, oh, these are optimization problems, and then you do them. Conveniently, the problems at the end of the section on optimization are about optimization, which means that you don't even really have to think about what kind of problem you're working, right? The book tells you. So, again, what you're being taught is when someone gives you the prompt optimization problem, you know how to do it. I got really good at those. But it turns out that that's not very satisfying, and it's not what math really is about. What you're really looking to do in math is that rhetoric, is to be able to look at a new math problem, one that you've never seen before. I don't even like calling them problems. To walk around in a new mathematical room, to inhabit a new mathematical universe, and to see where it goes, to see what you can say, to see, does this embed well into a larger rhetorical context? What can I do with this? And learning that looks a whole lot different than learning a big cookbook.